Alright guys, welcome back. We have question 15 from the fundamentals of electric circuit. In this video, we have the current entering the positive terminal of a device as this formula based on the milliamp, and also the voltage across the device is 10 times derivative of the current over time. And the question is asking us to find the charge delivered to the device from t0 to 2 seconds. And so we're looking for the charge in the A part. B part, we need to find the power absorbed. And last one, the energy absorbed in 3 seconds. So let's start with the first part where we need to find charge. We talked about it over and over in the previous videos. Our current is derivative of charge with respect to time. And here, if we just cross multiply this, dq is equal to I times dt. And if we do the integral on each side, that's going to give us the charge. And we are looking for the time interval of 0 to 2 seconds. So our I is 6e to the power of minus 2t, and that's going to be dt. Keep in mind that this is going to give us the charge in millicoulombs, since the unit that we have for the current is milliamp. So this should be pretty easy. It's going to be minus 3e to the power of minus 2t for the integral. If we just do the derivative of this part or this expression, we're going to get what we have under the integral. So 0 to 2, let's see what we get. We can just take the minus 3 out, so to e to the power of minus 4 for 2, and we're going to get e to the power of 0. And let's see what we get. So minus 3 times e to the minus 4 minus e to the 0, which is going to be 1. So that's going to give us 2.945. As I mentioned, the unit is going to be millicoulomb, and that's the answer for the A part. In the B part, we need to calculate the power absorbed. So we talked about it. Our power would be V times I, or the voltage times current. We already have the current, but for finding the voltage, we have to do the derivative of the current. So basically, our voltage in here, if we just do it in here, our voltage would be derivative of this expression, which is going to be minus 12e to the power of minus 2t. Keep in mind that we have a milli in here, so this is going to give us the unit in millivolts. So that's pretty easy. You just have to multiply these two and put the value that, oh, actually, we just need to find the general expression. We don't have any specific time point, so basically minus 12e to the power of minus 2t times our current 6 times e to the minus 2t, and we have milliamp times millivolts. So first of all, our unit is going to be in microwatt, and this is going to be minus 72, and this is going to be e to the power of minus 2t plus minus 2t, or minus 14. And I just remembered that I missed a 0 in here because it has a 10 times that. So here we're going to have 120, and this is going to be 720. So that's going to be the answer for the B part. And the last part, we need to determine the energy absorbed in 3 seconds. We know our P is equal to derivative of the energy over time. So our energy would be the integral of power dt, the expression that we found in the previous part, and we have to find this in 3 seconds. So we're going to start from 0 to 3 seconds. So this is going to give us, okay, minus the integral 1 minus 720 e to the power of minus 40, again going from 0 to 3 dt. And let's see what we get. I'm just going to take out the minus 720, and this is going to be minus 1 over 4 e to the power of minus 40. I'm going from 0 to 3 seconds. Let's see what we get. Minus 720. We can actually bring back the 4 out, so e to the power of minus 12 minus 1. Let's see what we get. 720 divided by 4, 180 times e to the power of minus 12 minus 1. That's going to be more or less minus 180. Yeah, right. So our value is pretty close to minus 180. And since the power was in microwatt, this is going to be on microjoules. And that's going to be the answer for the C part of the question. Hope everything was clear. Let me know if you guys have any questions. You guys take care. I'll see you in the next one. Have a good one.